another microscope. And this is the one I promised is going to be actually sometimes a little more problematic on the lights. So let me take you through this scope, show you something that looks quite a bit different. We call this a dissection microscope. One of the reasons is that if you got little bitty things like worms, for example, or insects, bigger kinds of arthropods, you can put them down here in a small way and you can look at them and they're still pretty big. You don't have to do anything special for the preparation of specimens. Okay, so sometimes little specimen prep, and in fact, we'll talk about looking at your own fingers right there under the scope. So that actually brings me to the first important point, which is when we use which kind of microscope. If we were to take a look at, I'm seeing a notice came up because the President of the United States was just impeached for the second time because of that horrible, unbelievable stuff that went on the 6th of January. Back to microscopes, because that's our point here. This microscope is different from a compound light in the way that we see specimens. Now, on a compound light microscope, I told you that we usually have very thin sections. I mentioned to you like slicing up bread, and then you lay those very thin specimens on a microscope slide. And when we look at items in the light microscope, the compound light microscope that we looked at before, it's a bit like holding up a piece of paper. Okay, so I'll grab a Post-it. And you hold it up and you look through it. Okay, so I might look at a piece of paper with light on one side and my eye on the other. Okay, and so if I'm looking at this piece of paper and holding it up to light, I can actually examine the detail of the paper. I can see a little bit about how they manufacture the paper. And this method, using light that passes through what it is you're looking at, and then to the receiving part, your eyeball, that's called transmitted light. Transmitted light. I don't know if you've really ever thought about it, but if you wanted to see what's on glass, you often have light shining through the glass, and then you notice, there seems to be like something going on that's on the glass, because you see it. There's something on the glass that interferes with light coming through. Okay, that's transmitted, and that's what the other microscope did. What this microscope does is what we mostly do. We see light that's reflected off of surfaces. So right now I've got a light right over here, and there's my hand. And I can see some of the details of my hand, or the details of this same sweatshirt I'm still wearing. Because light is coming from the source, the light that's right over there and also out there because it's the afternoon right now. And the light is bouncing off of these surfaces and coming back and is collected in our eyes. So this is reflected light. And that's a real important thing to make sure that you know the difference. Mostly compound light microscopes are passing light through a very thin specimen. Dissection scopes are mostly using reflected light, but I'll show you they can actually use transmitted light just as well, because we have two different light sources on this particular microscope. Before we do too much more, I want to talk to you about some of the confusing adjustments back here. This head of the microscope right here is pretty heavy, okay? And if I loosened up this top knob right here, it allows me to lift the head of the microscope up and down. And the reason that I might want to do that is that if I'm looking at something that's flat on the surface here, like that piece of paper laying flat, then I'm going to need to focus closer and move these lenses closer to the specimen. But if I wanted to look at my fist, the surface of my fist, or let's find here is a big bowl of, look at that, of paper clips. So I want to look at the paper clips. I don't know why. You could just take one out and look at it. But if you wanted to look at the whole bowl of paper clips, well, you're going to need to adjust this thing upward. And if you look right now, that's as high as I can adjust it up. And the paper clip bowl barely fits. But I can undo this knob and lift this thing up and then tighten down this knob again and now create a greater And I hope you remember what that's called, that area here. It's called the working distance. Okay, so create a greater working distance. Now this locks it in right here. What this knob does is it's sort of a stop. And if I bring this up underneath and tighten it up, so you can see me tighten it up, then when I loosen this one, this knob can actually be loose and the whole thing doesn't go past this knob, but it allows me to rotate the scope a little bit. Now more things about this scope. So this scope's quite flexible. You can put big things under here. You can put a softball under here if you wanted to. Or like I said, your hand or your foot or something pretty big. Now I said this is heavy. So once you have it up here and you're rotating this around, you should know, and you can see my hand here holding it down, this whole thing wants to tip. Okay, so it's real tippy. And you have to be really, really careful. Okay, so if you try to rotate it all the way around, like over here, it stops because it hits this post here. We actually could move this post a little bit. We could allow this to go all the way over to here on the other side. So now that would give you an even greater working distance, but it's going to tip over. So this is a good, expensive dissection microscope. I'm very happy with these, and you'll see why. It's got a zoom on it. It's really, really handy to use. But this isn't the best. It's not the best kind of dissection microscope that they make. And so they make other kinds that are more weighted and adjusted. And usually a particular type of zoologist purchases the type of dissection microscope that's best for their study, whatever the specimens are. And as we're learning in zoology, insects by far are the typical animal. So when you think of an animal, more than 70% of known species are insects. Of all the unknown species, of which we think there may be anywhere from 5 to even 30 times as many unknown species, we'd expect that most of those are actually insects. So insects would actually, we think in the real world, be more than 70% of all the types of species. So people study insects a lot for a really, really good purpose because insects play huge roles in our lives. Of course, they can be pests. They can be agricultural pests, but they also are pollinators. And so they're helping to move pollen between plants and helping to keep then angiosperms in their successful forms that we might find in a prairie or in our forests. Okay, so people studying insects. Lots of really important people studying insects for good reasons. This is the kind of microscope they would use. Okay. Now let's talk about that lighting, and this is one of those cases where I got to kind of turn things around a little bit and make sure you can see. Right over here is the main light switch, and that's great. And I just turned it on. There's not any light. So I can check that it's plugged in. Remember all those things that we said to do. I can check that the plug in the back is well seated. And there you go. You can see it's well seated there. And then see if you can think of anything else I need to do. And maybe remember those rheostats. Well, that's where this guy is really quite interesting because there's two light sources. On this side, there's a rheostat that I can turn up, and you can see that there's a light right here. See, it's dim, now it's brighter. Okay. So that's this light right here, and boy, I touch it right now, but you need to know this gets hot really fast. And many students who don't remember that turn their scope on and are working here, and then they somehow touch this, and you get blistered. You'll get seriously burned, okay? So you got to be careful. So I'm going to turn that one down there. And then here's the other one that we have on these scopes, and maybe you can see this. You know what I'll do is I'll turn off that light and see whether or not you can see this. It's going to be hard to do. But the base light right here, maybe you can see it, maybe you're not. It's not really showing up very well. I'm looking in the camera right here. Well, there you go. So there it's dim, and now you can see it's turned on. Now think about this. Think about these two sources of light. If I put a piece of paper on here, and I use the light that's right down here on the bottom, what kind of vision, what kind of image are we seeing? And the answer is transmitted light. I'll turn that light back on. The answer is transmitted light. So we can pass light through specimens on this type of microscope by lighting from below. Now, you remember that where we put a specimen that we look at is called the stage. Okay? And so if you think about the name for this kind of particular lighting, it's sub-stage lighting. That's what this is, lighting below the stage. So that's this one right down here. Okay. Now the kind of reflected light I was telling you about with my sweatshirt, that one is coming from above right here. That's that light. And that's light where if I wanted to look at my fingers, and I'm going to encourage you when you come to lab to look at your fingers, you'll notice fingerprints. You'll notice other things that are important in solving crime. So if I take my hand right now and wipe it across my sweatshirt and then put my hand under the scope, there's a really good chance that I'll see dark blue fibers on my hand because I just ran my hand over. And sometimes when people are fighting like that or hitting each other and then somebody's dead, we can actually find the fibers of people that might have been involved, the clothing of the people that might have been involved. You can also see your fingerprints. And one of the cool questions we're going to try to answer on this first lab on the peripherans, on the sponges, we're going to try to answer the question about sweat pores and your fingerprints. Turns out Charles Darwin's cousin, Sir Francis Galton, is one of the people that came up with the idea, realized that fingerprints look to be unique in people. And when he was thinking about fingerprints and thinking about sweat, he was hypothesizing what those fingerprints were doing. And one idea was that the groove of the fingerprint was a place to channel sweat. Well, where does the sweat come out? Does it come out at the top of a ridge or the bottom of a fingerprint groove? And that'll be for you to decide. You'll be able to go in, you'll put your hand under here, and maybe if you remember the commercial, they used to say, don't let them see you sweat. Well, in this particular case, we want you to see yourself sweat. And it's pretty neat. It's fun. And you'll see little bitty holes with this dissection scope, and then they'll start to glisten, and then it'll go away as it evaporates, and then they'll glisten. And those will be pores from sweat glands. Isn't that neat? Now, when you're looking through this particular scope, we do the usual separation of the eyepiece, but this one, by the way, will move separately. So you got to kind of keep them along the midline when you're looking here. Something I didn't tell you in the other scope is that each of these eyepieces, maybe you can see this one extending out and moving in. See, it's moving out right there. Now it's moving in as I twist it. Each of these two eyepieces on the compound light scope from before and on this one are independently adjustable so that as you focus here, if one eye is in focus but the other one not so much, then you can adjust this to make it in focus. We paid extra for that. Okay, cool stuff. Yeah. Another adjustment here. So the main focus, by the way, is just one knob. There's just a one single knob. It's not the coarse and the fine focus that we had before. But the other thing over here is zoom, and this is really cool. And this is part of what I wanted for you to have on this scope. Well, if you were to look really closely right here, if you can read that, it says 0.7. That's the lowest zoom, and then as I turn it, the numbers go up right here, okay? And as I would look in here, it would zoom in. I'd be looking at a smaller part of my finger. It would appear larger, I hope also clear, but as you zoom, you will need to stop and focus. So don't think that you will be able to zoom in and it stays in a perfect, nice, focused fashion. Okay, so you'll zoom a little bit and then you'll focus and look a little bit more and you'll be able to see those fingerprints. But just like with the compound light microscope, always start at the lowest magnification, get your bearings, see where things are, and then pick a region that you want to see in more detail and zoom in on that. Okay. There's other things that I'd rather you didn't mess with, but there's a screw right here that allows you to actually rotate this head. So you could be looking through the scope this way. We'd rather you just leave it set just like this. You might have to tighten that screw up just a little bit. And like always, guys, when you think something's wrong with your scope, think the light bulb's out. Go through that checklist, check all the things that you think you might not have looked for, and then call us over, okay? Because we want to take care of our equipment, and there's going to be things you forget. It's the normal process of learning. Don't feel too bad about it, but do try to remember all the things that you need to remember. In general, we're not going to have you getting out microscopes or putting them away. We'll have them on the bench top because of the pandemic. We're going to be much more careful about that. But if you did carry a microscope, we always hold it in two places. You always have one hand. See right there? That's the problem. This thing swiveled on me because it wasn't sort of locked in place, so I have to tighten that up. You want to have one hand under the base and one hand near the top. And that's a redundant way to be really careful, and then we usually carry them close to our body so that, again, we're kind of hugging the microscope, keeping it steady and safe. There are lots of fine parts inside, lenses and other things, that need to stay in alignment. So vibration is an enemy of microscopes. Scooting them across the table, moving them across the table, not good. Bumping them, dropping them, all really, really bad things. So we got to be careful. These microscopes I've recommended to a number of people. I teach 5th and 6th grade kids in a gifted class every summer down in Litchfield. And I recommend that if the family wants to pool together the money, and it could be expensive, but spending anywhere from $300 to $500 on a good dissection microscope is, I think, one of the best gifts that you could give to an 8, 9, or 10-year-old kid. Because it's the real world, and you just put it under the scope and you see it in more detail. And that's cool. So during this first lab on sponges, I encourage you to look at your fingernails, and that's gross. You don't want other people to see that, because I see people embarrassed all the time. They're like, oh my gosh, I thought they looked good. And then I put them under the scope. They're horrible. You might look at a fancy ring maybe that you have under there, and you'll notice how filthy it is. All kinds of crud that's inside on the details. Of course, looking at your hands, your fingernail, your fingerprints, and the pores for your sweat pores. I don't know if you've ever looked at salt, table salt, but they're little bitty cubes. They look like a dice. Now, they don't have the numbers on them. That would be really neat. But they look like little bitty cubes, almost all of them. Some of them are broken. But when we're salting our food, we're putting little dice all over our food, which is pretty neat to look at it. If you looked at sugar or artificial sweeteners, they look more like a powder, much more irregular and not so much fun to look at. When I do this for my gifted class, I have actually a full day with microscopes. And we stop and go outside, and I just let the students pick whatever they like, a little piece of a plant or some flowers, some clover flowers, for example. And when the students come inside, I tell them, look at the flowers. And invariably, they see animals, microscopic little animals, on those little flowers. And what they see are probably aphids, which are sucking the fluid out of the plant. So we'll have dissection scopes almost all semester. And as the weather gets warmer, I encourage you to find things that you'd like to see under the dissection scope. I think I'll tell you the story right now. One of the things that really made a difference in my life was when I put something, and that's what I'm going to tell you, under the dissection scope. I took a class on invertebrate zoology in my freshman year. I think it was my freshman spring or so. And I heard him talk about beetles as animals and worms as animals, and for goodness sakes, sponges as animals. I'm like, oh, okay, all right, well, that's not what an animal is to me, but okay, I'll take your word for it. And then one day I was in the dorm. It's kind of funny in the dorms, because if you're pre-med, we treated those people like they were physicians. No, there's a lot more training. Anyway, if you're a zoologist and you're in your dorm, suddenly I was Mr. Zoology. So when they found anything that was alive, they'd call me in. and a person had a tick, the gross things that are ticks. And they wanted to know, was this the tick that could carry Rocky Mountain spotted fever? So I had a little container, put the tick in it. It was alive. I took it to my zoology class. This would be really cool if you did stuff like this. And the TA, who was really, really sweet and a little strict, but if you behaved yourself, you could learn a lot. And she said, well, in order to identify the species, we have to look at the belly side of the tick. What are you going to do? Just turn him upside down, hold him, and look, And she said, no, and this is the little tricks that we do in zoology. She got some sticky stuff. I don't know. Could have been gum for all I care. And then we got the tick out, and we stuck the tick to the surface upside down. So his little legs are, going, but he can't go anywhere. And then we used the scope, and she said, you want to look at the pattern on their belly. All right. And so I got it all focused in. And I'm looking, and there's flashing. It's not a steady image. It's not the bug just moving its legs, but I'm looking at its belly, and I'm seeing something like this, flashing. And I said, if she could come over, I said, I'm going to take a look at this. Yeah. What's that flashing? She said, oh, that's its heart. Its heart? Now see, animals that I knew, they have a heart. I didn't know they had a heart. We didn't get to that part apparently, or I wasn't paying as much attention as I should have. Ticks have a heart. And it was that. I went home and thought about that. Made a big difference. Made me start to really understand that these really are life forms, sometimes with characteristics like us and sometimes not, right? We have 2 arms and 2 legs, and some animals like spiders and ticks have 8, insects, 6 or something else, some even more, right? Millipedes and centipedes, right? Crayfish have more legs. So they vary from us, but they still have some things like us, like a heart and a brain and eyes and other sensory input. So a dissection microscope made a big difference in my understanding of zoology. And I want you to be curious. When I recruit students for, so often they'll come and maybe as high school senior, maybe some of you, but this has been such a difficult year, I haven't been able to meet with that many prospective students, at least not that last year. I've been doing some on Zoom. But when I meet with students and we go through things and I give them some advice about going to college and picking a college, I tell science students that the most important thing you need to bring to college, you might think you got to pack toothbrush and cleaning stuff and clothes and who knows what, you got to bring curiosity. You got to wonder. You got to see something and go, wait, what? What is that? What's it doing? What's this flashing doing down here? Curiosity, the genuine desire to know answers. That's what's going to be one of the most important aspects of successful scientists. So I leave you with that. Okay?